Alright, there we go. See, there we go. Okay, dope. Yeah, there we go. For you guys watching the VOD, hi, hello, how are you? I'm just doing some random repairs and stuff. Right now, I'm modifying this Corsair 8. Ooh, don't drip solder in there. Modifying this Corsair ATX power supply to power a Sega arcade cabinet. Because it does. I've done some modifications to the cabinet and added some 12-volt lighting, so I needed a 12-volt power supply, which, you know, there's a lot of 12-volt on here. And 5-volt, does 25 amp, which the original power supply for the unit is like, what, 20 amp power supply? But it is, you know, from 1986 or 1985. So, you can recap them, but they're just not efficient. Ooh, bumped my light switch there. I'd rather use this that has, you know, overcurrent protection, short circuit protection. I know it's going to have really, really clean DC power because it is a switch mode power supply versus linear. And if you guys know anything about linear power supplies, hi. I'm glad I have older viewers. Or just general nerds. Yeah, they're not efficient, they're not good. Yeah. And the full bridge rectifiers and the capacitors and the transistors on those, and whatnot. You just have problems with arcade cabinets and noisy, lossy DC power. So we're replacing all the 5-volt lines. I'm still keeping the original transformers for all of your AC circuitry, so everything for the CRT, some of the AC lines for some of the analog inputs. Yeah, all that stuff is staying original. But instead of the little box that takes your 120 and turns it straight into 5 DC, we are going to have this. We have a power switch, and then ATX power supplies. They have a gray here is power OK, so I'm going to put a green LED between this and ground. So a couple of seconds after the switch mode power supply turns on, this puts out 5 volts, plus 5 volts. So that'll be like a power good light, and then this is the 5-volt standby. I'm probably going to put like a blue or a red LED between here and ground, saying, hey, power supply is getting wall power, but it's not turned on yet. Or I guess that would only be when I throw this switch, because I've got the power on jumpered. Well, I have it switched, actually. But yeah, that's your power switch. There's nothing on this pin. I don't know what I would do with that pin. Yeah, no, that I've got green on center, so I really can't do much with that pin. So right now I'm just twisting up some pairs. So we got 3 pairs of the 5 volt, 3 pairs of ground, and then an auxiliary ground over here for the status LED. So yeah, that's basically what I'm doing, is I'm just getting this ready to drop into the cabinet. And then I'm going to move on to some more interesting stuff. I've got a monitor over here that won't display red, 4K LG monitor. It's a, what is it? LG Ultrafine 4K monitor, yeah. That won't display red, so. I'm also wearing a lunch lady cap. I let my wife dye my hair. Fun times. But I figure, maybe 1 or 2 people will show up and hang out. Oh, hi. And listen to me ramble about electronics and see what I'm up to. Because I know how, when you go, like, vertical live, it'll just throw you on random live streams while you're browsing shorts. So, fellow travelers, while you're scrolling, come, stay a while, have fun, whatever. Flux on all of those. Just solder these together in big lugs. Where is my case of LEDs? Because I need to actually put their status indicator lights in. Let's see. Where does my chat even pop up on Shorts Live? I don't know. Is it a chat filter? All messages. Where do I even read the dang chat? I don't know. Maybe it pops up on my screen, I don't know. Maybe they copied, like, old Instagram Live. I don't know, I haven't streamed in a long time. I'm usually just making shorts about repairing electronics and whatnot. So I see there's a couple new people in here. I'm working on rigging up this Corsair power supply to run an arcade cabinet. Because I just have a bunch of these, and this one already had like a chopped line, so it was already bastardized. And I tested it, and it's good. So this is the 24-pin connector. These red lines are your 5 volt. These are your 3 grounds for the 5 volt lines. You have your power on, or your power good signal, which is 5 volts after the self-test is complete. So a couple seconds after you turn on the power supply. This is your 5 volt standby line. And here's a ground, so I'm going to put LEDs between this ground and these two. One saying, hey, yes, the power supply has power, and one saying, hey, power good. This is an auxiliary 12 volt that I'm actually just going to put, where did I set that guy down? Somewhere over here. I've got a blue, like, signage LED, just because, more RGB in your arcade cabinet is fun, I guess. This cabinet, I've added a bunch of 12 volt lights, like behind the marquee. The coin op, coin slots have a 12 volt, like, they came out of a bank sign, actually. Back when I was working, a 9-to-5 job, there was a Bank of America. You know how Bank of America just made some ATMs in a room and called them bank branches? Yeah, they closed a lot of those. So when the contractors came to, like, rip it out to empty out the building, they took the sign down and they just threw it in a big dumpster. So I had a whole bunch of these, where the hell is it? Actually, yeah, where did I set the LED down? I had it right here just a second ago. And I set up the camera to start streaming. And the rest is history. It's gone. It's gone. It's in the void. Who cares, I have more where that came from. There's only, like, so many places you can set a thing down in, like, this area. I'm sure I'm staring right at it. I'm mid, like, reorganizing and remodeling this whole area. I'm putting a fume hood in over here. I have a fume hood sitting in my living room, so that's fun. I just built this shelf over here that holds all my laptops and customers' crap. Let's see. Where do I? I don't know where I look at my chat here. Yeah, no. Maybe I should pull it up on a different screen. I put a screen up over here. I don't know. I guess we're having a one-sided conversation today. Sorry. Alright. Grab those. Yeah, I'm gonna put some crimps on the end of these anyway, so they don't have to be like perfectly tinned. But I do like to tin them up just to kind of keep them together. Makes them easier to route and manage. Alright. I actually really need that LED, so I can finish this, set it aside, and move on to the next thing. What's this? Oh, those are for guitar metal that I'm building. I don't play guitar, but I'm really interested in like audio effects, pedals, and stuff. I've watched too much brain rot on this platform, and I'm like, oh yeah, Harp Lady has some cool electronical toys. Oh, there's that LED. It's up there. Why did I sit up there? Okay, so I got this 12-volt LED. So this is actually a piece of a Bank of America sign. This LED. I just set the power supply like right there. Yeah, so that was one of the backlights for, like, you know, the always on sign. You know, you go by a strip mall and all the company logos are all backlit and stuff. This is what they're using. 12-volt LEDs. I think these are 3 watt or something like that. Does it say on it? It doesn't say. Right now it's drawing 0.7 watts, but let's see. Give it 14 volts is about 1 watt. I don't know. Maybe the other colors are a little higher wattage. It's pretty bright. It is monochromatic though, which, see, I didn't delete the fluorescent tube in the arcade marquee for a very good reason, because too much monochromatic light as a backlight for that kind of thing is going to make the colors look like nasty and washed out. So you still want that white backlight going through basically a color filter. But adding a little monochromatic light on top of that can really make the colors pop, and give it that kind of like Tron sort of feel. I don't know, have any of you guys seen Tron? Are you guys too young? Scrolling on YouTube Shorts. You know, you open the arcade machine and you walk in. That's why I'm even adding this light to this power supply in the first place. So yeah, this is going to power the logic board of the arcade. Status lights, and then this is just going to be a... Is the blue 12-volt line always on? Is that 12-volt standby? It might be. Yeah. Some heat shrinks over here. If it's 12-volt standby, even better, you know? I don't think it is, though. That heat shrink is way too long. There we go. That actually might be too short now. There. That's the money. There we go. My iron is a little too hot to be, like, soldering wires, like, floating in the air like that. Soldering wires floating in the air because it stays melted just a little bit too long. This ground is going to be shared with the other LEDs, so I'm not going to heat shrink that up yet because I need to put LED between here and there. I should probably grab like a little piece of wood or a breadboard or something. Maybe I could use this, like, yeah, that'd make a decent LED holder. That way I can keep it somewhat managed. Put both my positive legs there and there, and then both ground legs in this one. Yeah, one of those little cable braids. This is one of the many benefits of just keeping random junk strewn about the place, is you'll just find things like this that you can use for whatever you're trying to do. It's one of the only benefits of being disorganized. Is you get bonus creative uses for things you didn't know you had. Bonus use. Actually, I guess this is kind of the intended purpose of this cable comb. But you get what I mean. Shrink that on there. There we go. Now that cable comb will actually hold it. Got this one out here. Should probably pre-tin this. Flux. Yeah, I'm gonna pre-tin these. I mean, they're already tinned wires. It's tinned copper. But it'll keep them from getting all frayed up while I'm moving this over to the cabinet and whatnot. Because some of these are going to be crimped so that it's serviceable. Because serviceability is, you know, important as a repair tech. Good enough. Good enough. As I continue to mess with it. There we go. Cool. That is that. Sweet. That is done. Put that in my pile. Next thing. This one I've already repaired. I just need to put some parts back in here. Which is this crap in this little cubby. This is a Class D amplifier for a big PA speaker. And I was trying to diagnose it. It was a preamplifier problem. But I always take these, I'll take the output section MOSFETs out and some of the decoupling capacitors, and I'll run them on like the LCR meter like this. And that'll tell me, hey, it's a N-channel MOSFET. Its threshold is 4.5 volts and whatnot. Tell me the capacitance. And it'll tell me which pins are which. Basically, you take your MOSFETs, you shove them in there, and you see if they have decided they identify as two resistors instead of a MOSFET. Because that's typically the problem with Class D amplifiers that no longer work, is the output section. The MOSFETs that actually do the work in the circuit. These go to the preamp board. So I'll set those back in my little cubby. These two go there. These guys are from, let's see, was it the 4.7s that go here? Or are they hundreds? It's the hundreds, yeah. These go to the preamp board. Yep. So that's that. Quick little solder job. I mean, I'm the one that desoldered these in the first place, but you get the point. Shut those. Ow, what the fuck? Oh, I was stabbed. There's something sharp there. I thought I got shocked. No, I just got stabbed by something. Yeah, I need to like vacuum off my mat, get all the little tiny pieces of solder and stuff. Cleaning these silicone mats is like an art form. Put this up in the there we go. Hello, hello, welcome in. Alright, shove those MOSFETs in there. Through-hole stuff is so nice and easy. I love it. Versus doing all this SMD bullshit that I usually do. It's just a tiny bit crooked. It does not matter in the slightest, but aesthetics matter. There we go. Get flux everywhere. Par for the course. You know? Par for the course. I really need to change this iron tip. It has seen much better days. Like, it's still tinning up just fine. But you can tell it's been degraded and abused. Just like your ma. Reminds me of like Brooklyn Nine-Nine, where it's like fill in the blank thing you just said, title of your sex tape. Degraded and abused title of your sex tape. If you haven't seen Brooklyn Nine-Nine, highly recommend that show. Oh, that needs sucked again. And I'm not going to wait for this thing to heat up either. I'm just going to use my other iron. Let's see. It's going to hold that on the bottom, melt it. Hold that on the top and suck it. Yeah, that worked. Be impatient and use one soldering iron to heat up the other. Let's see, are we hot enough? Oh yeah, there we go. Where was I sucking? Beautiful. When I took the, this was all gooped up with this black junk. I hate it when, I mean, I understand why they do that in manufacturing. It keeps stuff from breaking just by, like, existing. This is like a portable, like, 3,500 watt PA speaker, right? It is actually, I got the thing for it over here. It's a, oh no, this is a 1,000 watt unit. The JBL over here is the 3,000. Yeah, it's an Alto Professional powered loudspeaker. I don't know. I guess these are nice. It's like one of those big powered speakers you use for, like, I don't know, like a college party or some shit. Or if you were like, I don't know, a street performer, something like that. They sound nice. My cameraman has a whole bunch of them. This actually belongs to my cameraman. But when I took this goop off this amplifier board, took some of the heat shrink off these capacitors. Who even makes these fucking capacitors? Jamicon. Yeah, I don't think that's a good brand. I'll probably end up replacing these anyway. Since I'm in here doing work, that's why I have all these caps pulled in the first place, is I intend to replace them. But I want to get the unit back together and test it after I fixed the preamp board, which is this. It's missing an op amp here. Here's my little paper. These are all the little S&D components I pulled off here. Basically, this was at a college party, and somebody spilled beer in the XLR jacks. So I got an XLR jack sitting over there in my parts bin. That goes here, and like this op amp and everything around it. It's a Texas Instruments. What is that? A 4558. Is that what it says? 4586. I'm blind. 4580. It's a Texas Instruments 4580 operational amplifier, which this is the same chip that you see like repeated all over this board. And these are all the same chip. Same circuit. They're just stacking a whole bunch of them for each of the different split channels, because this, I think it splits like by frequency or some shit like that. I don't know how it works specifically. I'd have to stare at it longer than I really need to fix it. See, that's the funny thing, is you can understand a ton about electronics and be terrible at repair. Or you could be like me and be pretty good at repair and understand a lot about electronics. But you definitely do not need to know how something works to fix it. You just need to have good critical thinking to find the problem. Probably shouldn't last 400-degree air at some electrolytic capacitors. That would make them go bad really, really fast. They do have a liquid in them. There we go. Sometimes the cans on these are have continuity with like the negative terminal of the capacitor. Some of them it's isolated. Either way, I don't want to fuck around and find out with those. Get those back on there. Let's see. Hey, 2 people in here. Hi, how's it going? Mm-hmm. I don't know. I don't see like a chat pop out or a chat thing. So if you guys are talking, hi, how are you? Sorry, it's kind of a one-sided conversation. I need to pull up the stream on like a laptop or something over here so I can actually read the chat. But yeah, this is, I don't know how long you guys have been here. This is just a Class D amplifier for a big old PA speaker. And I kind of tore it down a bit more than it actually required. Because, you know, my cameraman handed it to me is like it doesn't amplify. So the first thing I check is the amp, of course. And the thing about Class D amplifiers is a lot of the components that are likely to fail, you have to test out a circuit, which is annoying. But yeah, if these caps boiled off their electrolyte and gained a higher ESR or lost value, yeah, you wouldn't be able to tell on these, because you're going to have a lot of other capacitive components in parallel with them on this circuit board. You can definitely tell if they're like shorted, but that's usually not the issue with these. It's usually that they've gained an equivalent series resistance, or they've lost capacitance, or their ripple has gone down. And they're not doing their job, which for these specific capacitors would be decoupling. These are not filtering capacitors, these are decoupling capacitors in this application. But there's some crappy, cheap Chinese. I have good 100s, don't I? Save myself a little bit of time. dig around in the mixed parts bag. That's a good 270 polymer. I don't need that right now though. Those are 100 microfarad, 16 volt. I swear I had a whole bunch of those sitting around. Set this Fender preamp over here. I need that. That's important. Put that in the thing as well. Yeah, no, that bin's mostly my big caps. This organization is going to be the death of me, guys. There's no two ways about it. Are these those? Yeah, that's what we need, is those. I had them just kind of like strewn about up here, and I picked them up and I put them somewhere. But these are like really nice Chemicons. I like using those. One of the drawers to one of my tilty bins is just sitting here empty. Christ. Yeah, I really need to like spend an entire couple days just organizing shit around here. PlayStation MOSFETs for PlayStation 5 boards. Well, I found one of those nice Chemicons. Is there another one just chilling up here? Perhaps. Yeah, 50 volts, some syringe needles. 50 volt 10 UF. And that's a crappy one too. Yeah, I'm not sure exactly where I threw all those. I know I put them in like one of these little bins of some sort. There's another 100. It's another Chemicon. I know that's an Inchicon. Fine gold. They don't make those anymore, but they are good. It's funny. This is what like 10 years of technological progress does for the same part, same value. Oh no, actually that's 10 volt and that's 25 volt. Never mind, don't listen to me. What are these rated? 16? Okay, I probably shouldn't use that 10 volt rated one then. That would be bad. That would be a no-no. It'd be a bad thing to do. Let's see. Why is the video? You know what? I think my freaking... Yep, that was dirty. I'm a professional, guys. Trust me. Trust me. Alright. I got a whole bunch more of these sitting up here. That one. Now that's all like HDMI ports, USB ports, shit like that. And an iPhone. Back glass. Yeah, finding anything in this lab is kind of a nightmare at the moment, because I have to clear everything off that side of the workbench to get my fume hood in here, so I've moved so many things in the last couple days that I'm just completely lost when I'm looking for anything. I'm that kind of person, is like, I know where everything is until I move it to, like, you know, when I organize things, I can no longer find things. It's funny. Yeah, it goes up here in the Gridfinity, or not. Yeah, I'll just throw it here. Okay, that means it's over here in this bin. This is the bin that I was just dumping stuff in. That normally lives on the other side of the workbench. Like the crate of all the kits. All of the kits. Mostly screw kits. You know what? I have like a huge order of capacitors coming in from Mauser or DigiKey. Oh hey, look, there's another fine gold in here. Never mind. Don't need to compromise and use like these shitty Chong X Chinesium capacitors. I don't trust those things. I wouldn't trust them to do anything important. These fine golds, these Nichicons, came off of a old Asus sound card that came in with I bought it from Japan, and it came in non-functional, and I poked around on it, and like the proprietary like Asus like audio chip, like the digital processor, was completely borked. So yeah, that was fun because I bought it as it was sold as working too, was the issue. I just don't think the person that was selling it had the means to test a PCIe sound card, because that's like such a weird thing in current year. You know, if you were building like a gaming computer in like the 90s or early 2000s, you'd get a sound card. What did I just do with those PlayStation FETs? Because here's the big bag that says what's in it. And I put them in the little static bag, and then I set them down somewhere. Christ. It's too late at night for this shit. I don't care. We're doing the Louis Rossman special, guys. We're gonna be working till 4 in the morning for no goddamn reason. That's just how we do it around here. That's what we call the Louis Rossman special. These are just like slightly bigger than the original ones, so getting it. And there's a little bit of a squeeze. There we go. That's tight, to say the least. Alright, we mount all of those. Now let's get the, I don't know where my little squeezy bottle went. Probably on the other side of the room. Mm-hmm. I'm just moving all kinds of shit around places it doesn't belong today. See, the trick with getting solder flux gunk off boards like this is you just do a half-assed job and throw it in the ultrasonic cleaner after you're done. That's one of the nice things about having an ultrasonic cleaner. One of the very, very nice things. I did not get those joints tinned up properly. I just like tacked it in place. That's good, that's good. Alright, all good. There's that done. That goes over here. Let's see, what's next? Alright, I gotta clean this up because I gotta do this monitor. And I can't be scratching that screen up. So this has gotta get clean. It's gotta get clean. Which means all these things go back where they belong. That's not where that belongs. But that will work. I'll be able to find it when I need it. Alright. Much nicer, much nicer. Alright. Change gloves, because those are covered in flux and lead. Alright. So, I've got duct tape, or not duct tape, packing tape covering the screen so I don't scratch it up. This is a 4K LG ultrafine display. It's a Thunderbolt Type-C display, and this fucker won't display red, and I'm going to try and see if I can figure out why. It's definitely a hardware issue. I've plugged it into both, like, well, I plugged it into all three major operating systems. And I've tried, like, applying a new ICC profile, and whatnot, but, yeah, this monitor just refuses to display the color red. Like, green and blue, perfect, fine. So I think it's probably something wrong with the logic board in here. Either that or the, like an encoder or decoder chip or something like that. I'm hoping it's, going to be fairly easy to diagnose, but we'll see. We will see. Oh, there's all kinds of adhesive stuck to that one. Where's another Jimmy tool? Actually, you know what? I can just wipe this off. It'll be fine. Don't be lazy. So yeah, this monitor refuses to display the color red, and that's kind of weird. I saw a Reddit thread out there saying they had the same monitor with the same issue, and then I saw another thread about this monitor's big brother, for a lack of a better term, the 5K ultra fine display, with the exact same issue. No one said anything about getting it fixed or figuring out what was causing it or anything like that. They're just dead threads from a couple years ago. I think this monitor was released in like 2017. And this is like an $800, $900 monitor. I don't know if it's specifically advertised towards gamers. I think it's more advertised to like creatives for like studio work, graphic design and video editing and whatnot, because it's definitely intended for Mac users, as it's, you know, Thunderbolt only. So you can use your USB 3.2 and above Thunderbolt compatible cables with like the new Macs. They're all Thunderbolt over USB Type-C. I gotta move you guys back just a tad. There you are. Like right there. Seems like it's just a bunch of plastic clips here. I got a tool for that. The triple XL spudger. I'm gonna get this side started with the jimmy tool, and then we'll shove this. There we go. There we go. That's got money. Yeah. Alrighty. This thing is at least it's kind of well built. Looks very well built compared to a lot of the monitors I've opened. You'd hope so. This thing's what, $800, $900? Let's see. So this is probably our backlight here. What does that say on there? Can't read. VCC, SCL, SDA. Okay, so that's an I2C interface. That's interesting. Yeah, we got TSDA, TSCL, SCL, and SDA, and then VCC and ground. So yeah, that's an I2C interface there. What that's communicating to could be the backlight chips. Could be a number of things. Main boards here, I assume PSU's this area. Active cooling on a monitor. That is something you don't see often. Active cooling. We like active cooling. Active cooling is nice. Now that I'm in here, are there any buttons for like service? That'd be nice, because that's the other thing about this freaking monitor. is there are no buttons on the entire thing. Only Type-C ports. No buttons. So you have to use LG's garbage proprietary apps to change any of the settings, and like it's just kind of a pain. Yeah, this monitor would be really nice if it had DisplayPort, a power button, maybe an HDMI port, just for some of those legacy devices. Then I'd say it's a nice monitor. But these might have a major design flaw, since they just decide fuck the entire color red. And we're gonna figure that one out. So Linus, you have been summoned. Probably need a dish for all of our fasteners, because the ones I already took out, I just taped to the plastic piece. These screws aren't important. There we go. So yeah, how's it going, guys? Welcome in. We are figuring out why this $900 monitor won't display the color red at all. I assume I should probably go for the screws with the arrows first, huh? I need to use both my hands and more than 2 of my brain cells. Also, my voice is just kind of gone. Ugh. Where'd my voice go? Don't know. There, that's much better. All right. So yeah, this monitor won't display the color red. Why? Tell me why. Let's see. That is aha. So we take this whole panel off somehow, and then I have to unplug the speaker, like, up and behind it and all that shit. That's fun. Which the speaker plugs in up over here. Alright, this is gonna be fun to tear down. You know what, I want to go even faster. Get out the big iFixit driver. That ribbon connector looks fine. Alright. Is it built like a $800 monitor? Yeah, I'd say so. This thing's fucking solid. It is, in fact, solid. Like, this isn't even like that cheap, thin sheet metal. This is like nice. And it seems like they're using one of those like automotive like dimple presses to like shape this stuff over here. It's like face-to-face deformation, I think is what it's called. Something like that. Where they have basically like a stylus and an anvil on two sides of a piece of sheet metal in manufacturing, and they go like, and just kind of like hydraulically press them together. And they're on robot arms. I don't know if you guys have ever seen that done. There's a rabbit hole for you for later. Is go look up like sheet metal like deformation manufacturing techniques. So I guess it's time to get rid of this plastic bezel as well. Some of my packing tape is screen protector is stuck to the bezel. There we go. Set that aside. Let's see. Is that glued? No. Alright, so that's free. That's unplugged. Let's see, is there any, yeah, there's one additional flex cable here. And I should be able to, is there a latch on that one? Oh, I think I see why, I think I get it. I think I get it. I see potentially where you could have a problem with this specific monitor. So this fan blower is blowing directly onto one of the display cables here on the back of this panel. So you might have like an Apple engineer problem where you know, you're sucking in dust, dirt, and debris and spraying it right on like a very essential circuit. That's a possibility. Because it seems like this just kind of cools the entire back of this plate here, which I think I have to take this black board up here off in order to get this the rest of the way off. Yeah, there's an arrow up here on this screw. So black plastic board. And then does that unplug over here or on this? Probably. If it wants to cooperate. And let's see, will this black plastic thing come up? Or do I have to pick up this board too? Probably. That seems to be the procedure with things, is remove all of the visible screws, right? When in doubt, remove all visible screws. Okay, no hidden screws under there. Those are some big thermal bonding pads. I guess either these chips or these inductors get quite hot. I mean, it is a 4K panel. They're not exactly the coolest running device. That's ever been engineered. So there's that board out. Yeah, I see a lot of dust and debris like right in this area where the fan's blowing. So I'm wondering if that's like... No, I don't think that ribbon cable is like poorly insulated enough for that to be an issue. But I have a feeling our problem is going to be down here or on the logic board where this ribbon cable connects to it. So I'm going to move the panel out of the way. This is a thick, nice panel too. Like, yeah, it's well built. Honestly, like, even better built than, like, you know, some of the Samsung TVs and stuff. Like, this is one solid billet of aluminum machine down here that's covering, like, your encoder, decoder boards, or chips, boards, chips, whatever. You know, all of the display information goes through this ribbon onto these, and these kind of like multiplex it out to each section of the displays. How these IPS panels work. Alright, this can go on my other office chair where it won't get hurt. And we can look at the goods. Alright. Okay, so I see this is blowing straight down, and also I'm assuming it's blowing your main processor chip over here on this. Oh no, the main processor's over here. I guess it's cooling the power supply. Interesting, but makes sense. Now I can finally get this speaker unplugged. I hate this style of connector. They're just never easy to work with. Come on. I have a suspicious feeling that that connector is plugged in before this board is screwed down. Because there literally just is not an... Like, this is in the way of this unplugging. Like, there just is not enough room to unplug that when installed. So that's interesting, design-wise. Yeah, this definitely feels like Apple engineering. If you guys know about Apple engineering, we make questionable choices with Apple engineering. Like putting PP bus 3v3, or no, it's PP G 3v3 hot. Putting that right next to the 40-volt backlight rail. That's always fun. Or just, you know, letting that line short straight to ground. Because it's right next to the fan intake. Or something like that. I don't know. I don't work on very many MacBooks. I say that and I have 4 MacBooks over there in my queue, but that would account for about 30% of all the MacBooks I've ever actually repaired. I tend to do more audio equipment and smartphones. Big thermal pads. Look at the imprint of all those SMD components and those thermal pads. That's kind of amusing. This is heavy. This is thick stuff. It's like 0.8 millimeter thick sheet metal. Which kind of explains why this monitor costs $800, $900. That money is going somewhere, for sure. Let's see, yeah, I probably need to take this sticker off the Type-C ports. Which, this sticker is good design. It keeps foreign materials from ingressing onto your logic board. There's a big SAT word for you guys. Ingress. Ingressing. You guys ever play that mobile game Ingress? It's like the predecessor to Pokemon Go. I used to play the shit out of that. That's a big chip. Yeah. Logic board. I wonder if I could find a schematic for this. I highly, highly doubt it. Yeah, even this shield on the USB-C is 0.8 millimeter thick sheet metal shielding. There we go. Finally got that speaker unplugged. There's that. That's one beefy power supply. I kind of want to pull that out and just look at it. Nerd out about switch mode power supply design. By the way, these speakers, these look very nice. They've got like that grommet mount thing you see in high-end speakers that are assembled inside equipment. You've got like 3 different size drivers. And they just feel good. Got sound dampening foam everywhere it makes contact with the back of the case. That speaker unit is made by Ledger. I've never heard of that company. Ledger. 24M D4K. Oh no, that's LG EKR. Okay, so LG also manufactures the speakers. That makes sense. That makes too much sense. Alright, set that over here, out of the way, and we will take a look here. So, oops, turn off my light on me. Might have to drag out the microscope for this one, because this is a very dense board for a monitor. Let's see. It's blowing out my shot. I don't know, what if I, can I still see pretty good through the microscope? Yeah, I can see all right. Um, yeah. I still have no idea where chat would pop up on here. I guess it would pop up down here somewhere on my screen. Alright, let's take a look here. So I'm looking at this connector here. Just see if there's anything screwy going on over there. Is that blowing out the shot? Yeah, a little bit. Oh well. If I bring the camera in closer. Hi. My wife dyed my hair. Let's see. There we go. Now you can kind of see what I'm looking at. Let's get that back. There we go. That's not too bad. That's not too bad. Orientation. Yeah, I know your orientation is locked. This is the frame I want. You're looking down, YouTube. It's like, yeah, you're in vertical mode. I know. I know. All right. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 like pairs of obviously data lines going to this big chip over here, and we got a bunch of probably very low impedance filtering capacitors on all of those lines here and here on those lines. What does that say? That's a little... I can't read that silk screen, but it's either an R or an A. And this component is going across this line to ground. Alright. So I'm going to put my black probe on ground and just start seeing what's going on over here. That's a ground plane, right? Yep. And continuity on the other side? No. Wait, I should do this the other way around. Red probe on ground. Black probe. Testing. Let's see. Good. Why do we have capacitors between two ground planes? Because that is all... Oh, I guess there's an inductor between that ground plane and that ground plane. Interesting. Well, actually, you know what? No, that pad there is short. No, that has continuity to this. It's this side that's the shorted side. Because that is... Yeah, we got a short here. Let's see. 34 ohms. 34. Also 34. That one's 33. 32. Yeah, it's probably one of these two that's bad. So I'm gonna pull. Let's see, if I pull that, does that short go away? Actually, what is that, let's see, I'm looking right here. That might just be low impedance. I'm getting like 30 ohms to ground. Which, well, let me try a ground that's a little closer. What if I... Yeah, still 30 ohms. That might be normal. That might be normal. Well, actually, no, because these are mirrored circuits here. Right here and right here. And I don't have 30 ohms to ground on this one. And I do on this one. And, like, you got the same components and the same configuration. In fact, the ground pad is shared between the two. And they both go to, like, a set of vias. And this IC. The big chip. Yeah, let me double check that I'm not completely freaking losing it, but I do believe. Poke that. Yeah, see, this open line. Same circuit over here. 30 some ohms to ground. Yeah, it wouldn't make sense to have all of these big capacitors right on ground. What's on the other side at? Over here. On the other side of that, a couple little resistors. What looks like EMI chokes. AR. What does AR stand for? A little 4-pin passive. Looks like a filter. That's what it looks like. And those are filtering what are obviously data lines. Oh, hey, look. Here's that same circuit. Like that same pattern of inductor and the 3 big caps. Right there and right there. So I bet those are like the main power phases. Like, you know, we got 4-phase power. We've got some MOSFETs there. And there are some diodes and MOSFETs there. Let's see, power does come in from this side of the board. Let me poke where was I at here? Let me poke these ones and see if these behave the same as the ones on the top side of the board, or no. Open line there. On that cap. Open line there on that cap. So we have 4 like nearly identical looking bits of circuitry. And that one reads 30 ohms to ground. So that is definitely an issue. You just would not have 4 identical sections of circuit where you have like this value cap, this inductor in that footprint pattern, and have one do a different thing. That just doesn't make any sense. So the issue has to be here on this circuit here. So that one of these capacitors is definitely shorted, or this chip is shorted on these pins over here, which I wonder if I can find. That's a Realtek chip, so I might be able to find a data sheet for that. Here's a life hack for you guys. If you ever have like if it's hard to read, what I do is I have one of these Sharpie paint pens, and I just silver paint, I rub it in, let it sit just a second, and then I take like a Chemtech wipe or a little paper towel with some alcohol. Alcohol is kind of very necessary for this. Give me another wipe. Yeah, that engraving is not deep enough to like for this to be as effective as it normally is. But the idea is like where they've laser engraved the part numbers, you're filling like the low spots and wiping away your pigment from the top spots, but it's not going to work on this chip. Maybe if I use a yeah, see, that's why I use the silver paint pen, is because it contrasts with the black. Because, like, any permanent marker color, like this red, just isn't going to have enough contrast. So I guess we're just going to go the route of, like, cleaning the chip real good and, like, tilting it in the light to read the part number. There we go. RTD 2795T. I bet that's like an FPGA or something. We'll see. RTD 2795T. Hang on one sec. I don't need these. RTD 2975. RTD 2795T. 2795T. Let's see here. Realtek datasheet, yay! Multimedia SoC with AP router, HDMI, USB 3.0, SATA PCIe, SDIO, and DTV. 64-bit ARM processor is what that is. Okay, my phone is getting low on power here. Give it the whoop. So yeah, it's a 64-bit ARM processor. Of course, the site that has the information about that chip is in fucking Chinese. So this chip has a UART interface, like GPIO. Doesn't say what pins it's on, but I wonder if there's a serial interface somewhere on this board, like some test pads that I can poke and see if I can get like an error code off of it or something. JP. Yeah, all of the debug only. There we go. That's probably our UART interface. So if I grab one of these little boards, this is a Silicon Labs UART to USB chip. I can probably see that's going to be your 5-volt there. And then I got 3-wire. What would a 3-wire protocol? Okay, so that's 5-volt. One of these is going to be RX and TX. Then we got 2 ground pads over here. It looks like I have 3 data lines, but nope, 3 data lines for a debug port. That could just straight up be USB. Potentially. Debug only. Well, I'm gonna hook up some jumpers and power the board and see what happens. See if I can read anything. Let's see, you got GPIO, SDIO. What does SDIO look like? Oh, SD is like, that's literally like SD cards and shit. Okay, so that's not what it is. So yeah, this is probably our GPIO. I wish I could get a pinout on that thing. IR. Oh, I see. So it said it's got an infrared line for like a remote that is probably an NC, but it's like IR, RX, TX, and then VCC and ground. There's 2 grounds on this for some reason. So, yeah. Let me get some little jumper wires and we'll get this bitch figured out. So, yeah, move the microscope out of my way. Bring you guys back up. Up and over. So yeah, that debug only port, I'm gonna have to figure out which pins are which. So I like to use orange for TX. When I'm doing this with like PlayStations. I need more of these little GPIO jumpers, which are in this box up over here. Oh, I moved that box. Where did I move that box to? Here we go. You have 100 billion of these little freaking things in the way until you need them. Until you need them. Then you have to go hunting them down. Bidirectional level shifter, stepper motor controller. There we go. Yeah, that's enough right there. I wonder if an infrared universal remote would work if I hooked up an infrared diode to one of those pads. That would be interesting to find out, because the ARM chip that runs this board does support it. So RX is going to be blue. You know what? I'm just going to use iron. Went into standby because I wasn't soldering anything there for a minute. I'm just going to use the hard solder pads on this thing, because these little jumper wires aren't like the square one. You guys know what I mean? The square one. I need flux. Give me flux. Bloop. There we go. There's RX. Red's gonna be TX. Oh, you know what? One of those pins might be reset, actually. Might not be IR. The IR might just be like NC from the ARM chip. But that is on its list of GPIOs, so I doubt they'd put an IR pad on the debug connector. Alright, there's RX and TX, and then ground. We'll go... I'm not going to use that for ground. Where'd that... orange one go? I threw it. Oh no, it's right here. And ground on this board is here. So, ground. No, let me get a longer wire for ground. Just shove that pin in there. Flux tube. And then I just need to plug this into like any IDE and tell it to serial read on, when I plug this into my machine, it's COM3. And this device is called Silicon Labs UART bridge, or something like that. So now I just need to figure out which one's RX and which one's TX, which that's going to be a fun job. And then once I'm serial monitoring the debug port, it might all just be like gibberish error codes or gibberish code. So this might be a fruitless endeavor, but we'll see. Maybe there'll be some useful information. I should probably just go back and try and find where that that one line that's obviously got a problem is shorted. But I kind of want to see if I can figure out what the debug pinout here is. So that says plus. I'm going to assume that line there is TX first, and then figure it out from there. I need some flux. I keep throwing this flux tube and then kicking myself because I can't find the flux tube. Get that hair out of there. You don't want to solder hair into your debug port. The added fiber does not improve communication. Then tin up the tips of these little jumper wires. By the way, if you're shopping for like electronic components and you're buying like these pre-made jumper wires, just don't buy them from China. You used to be able to get like actual copper wire in like little jumpers and clips and stuff, but these days you'll get nickel and iron wire instead of actual copper wire. It'll be like steel wire coated in copper or nickel wire coated in copper. I saw a pretty interesting video about that the other day where he was having, some guy had just bought some those like alligator clamp jumpers, right? From China. Like AliExpress or some nonsense like that. And they turned out to be steel. So he bought more, and they also turned out to be steel. And he couldn't find any alligator clamps on like Amazon, AliExpress, like any of your big marketplaces. Couldn't find any alligator clamps that weren't complete garbage and made of steel instead of copper. So if you've got good actual like, okay, I'm just gonna chop and strip these because whatever, these nickel pins don't want to solder nicely. So yeah, there's these with the real copper. If you have them, hang on to them, treat them well. Or just, buy that sort of stuff on DigiKey from a reputable vendor. That's what I do. You can get test leads on DigiKey. Mm-hmm. Or just make your alligator clamp jumpers yourself. It's not hard. You just need a crimper. That's it. Alright, so we're assuming that pin is RX and this pin is TX. If I don't get any data when I boot this board, I will reverse those. I should probably use micro pencil iron for this and actually solder this under the microscope. Because with this big iron, with the big iron on my hip, things are just going everywhere. So I'm gonna use the Keon Lee mini micro pencil iron here. Where did the cord for that go? There it is. I've got one of the glass panels to an iMac just leaning over here, just off screen. Almost knocked that over. Alright. Somebody's still watching. Cool. Hope you're enjoying the show, I guess. Let's see. Yeah, when you actually use the microscope, microsoldering becomes easy as shit. There we go, done. Alright, so that's hooked up. So I can hopefully serial read that debug port. Because that might tell me if there's some like low-level error that it's actually reporting back to Mother Brain or whatever. This glass I've tried to reach through this glass panel like 7 times today. I need to move this. Put it back on the stinky old iMac. There we go. Yeah, just one of those big, stinky 2010 iMacs that I found in the trash a while back and haven't bothered to repair because what the hell am I going to do with a 2010 iMac? Like, even a modern Mac is still a Mac, you know? What am I going to do with that? I'll tell you what I'm going to do with it. Sell it on eBay or Facebook Marketplace. I have no use for a 2010 iMac, you know? But I found one in the trash and it works. It needs the OS reinstalled. That's the only reason it's over here in the first place. Alright. Anyway. I was in a polymide, Klepton tape. Where did I put the funky space tape? There's a fun fact for my one viewer. Polymide tape was originally created for the aerospace industry. Yeah, it was like a exotic space material. They needed something that was insulating, lightweight, and very, very temperature resistant, extremely temperature resistant, because you'd be dealing with extreme high and low temperature, and they needed something that would stay adhered and continue to be an insulator. And that's how Klepton tape was born. If I could find where I put the entire roll of this shit. Did I shove it like up under here or something dumb? I don't know. Disorganization is going to be the death of me. Whatever. We'll use crappy blue masking tape instead. It does the same thing. Sort of. Keyword sort of. My voice is going. Going, gone. how... Okay. There, now those solder joints are not going to literally rip themselves off the pads, and maybe even take the pads with them. Alright, now, coming back to the short circuit over here. Again, sanity check. Yep, definitely short on that line. In my experience, usually when you have like a pad like that, it's a power phase and it's shorted, I usually start with the smallest capacitor, decoupling that pad first, and then work my way up to the bigger ones and see, removing them one by one and testing to see if your short circuit is gone. That's usually how I go about this. So just dab some flux on there. Grab it at an 862D. Give me a post-it note. I like to use like the crappy adhesive on the back of the post-it note to hold like little S&D components. So that I don't lose them. God, I hate unleaded solder. How long do I have to blow 400-degree air on a solder joint to get it to melt? Ow, hot. There, just add a tiny bit of leaded solder to that joint and watch, it's going to come up easy now. Boom, there we go. If the fucker will stop sticking to my tweezers. There we go. All right. Cool. Let's see. Is that Jesus? My voice is so fucking gone. Is that line still short-circuited? Still short. Still short. Okay. Did I really just... I did. I did. I just wiped up my capacitors. I fucking hate how dumb I am sometimes. I thought I stuck them to the post-it note, and no, I had not. They were sitting right there. They're gone. Cool. That's fun. Oh, hey, there's one. Still sitting here. So that's cool. There's another. I only pulled up 3. They're probably still all on the mat. I didn't wipe this too aggressively. Another one's probably stuck to this cloth. It doesn't matter. I can just get a value off those ones, and I have SMD books for a reason. Oh, hey, there it is. I found it. Haha, nice. All right, now let me get a fresh post-it note here. That's the sticky side. So I like to just, yeah, stick those tiny little components. Yeah. That is absolute streamer luck right there, that I didn't lose those immediately after not putting them somewhere where they won't be disturbed. So yeah, now I have them stuck to that post-it note. Be impossible to lose those now. Alright, moving on. Oh yeah, I wiped all the flux off this board already. All right. That right there with the alcohol, that's what I call encouraged cooling. Probably not that great for the solder joints, honestly. But it hasn't screwed me over yet, so I will continue to do it. Alright, stick these capacitors up on my little post-it note here. As I get alcohol all over it. Actually, they're wet with alcohol, they're not going to stick. The adhesive on these post-it notes is already pretty weak as is. You know, sticky notes were like an accidental invention. They were actually trying to make like a good usable adhesive, and they accidentally made one that was like garbage, or so I've been told. Yeah, and they accidentally made like a garbage adhesive, and they're like, you know what? This is really nice for temporarily sticking something to something else. Let's put it on pieces of paper, and boom, post-it notes born. Or so I've been told. Citation needed, you know. Citation needed. Alright. So, did that clear our short circuit? If it didn't, I'm going to be upset, because that means it's the big stinking chip that I probably can't buy. Okay. Fun. That is just fun. Actually, you know what? That inductor has like a tiny little like center trace there. So like the ground, this ground plane here goes under that inductor. For what reason? Your guess is as good as mine, because this trace literally goes back up and around here. So what? Maybe that's just what the CAD program this was designed in decided to do. Knowing like Eagle and ECAD and stuff like that, Fusion. Sometimes some of the ways it decides to like etch PCBs is interesting to say the least. So that line is still short. Huh. I bet you each of those is a power phase. You know what? Got to, like, obviously, like, SOSP8 form factor, or TOSP8. These are probably MOSFET arrays right here. They probably switch the different power phases there. Yeah, you probably, yeah. Got inductors here, MOSFETs there. Those are probably power phases. Yeah, especially because the pad that's short goes to several pins at a time on like a big plane that isn't ground. And we have this identical circuit, like this identical pattern of inductor and then 3 large capacitors here, here, and we also have the same pattern here and here on the back of the board. Same pattern. I bet that's the exact same. No, that's actually under the main chip. But like similar trace pattern, same inductor, same 3 capacitors. Equidistant to each other, ground plane. And then some data lines are adjacent over there. Probably the same data lines from over here. And I don't have that 30 ohm continuity to ground on any of the positive sides, any of these capacitors. Here, there's actually another one over here, and over there. Yeah, same pattern. Oh, and look, here's two more. Yeah, each of those have to be a power phase, because they're like an identical footprint. You got 3 capacitors, inductor, 3 capacitors, inductor. Same pattern. This one's arranged slightly differently, probably due to just space constraints in that area of the board. Then you have another one down here and another one down here. I wonder if one's like positive supply voltage and one's like negative, because they seem to be in pairs of 2. Because you got one there, one there, one there, one there, one there, one there. Then you got these 2 back here. But I'm going to poke these ones that I just now noticed and see if they are behaving the same as the rest of them, except for that one. Or if maybe... Yep, see, I poked the inductor side of that one. No continuity. That one there has 30 ohms to ground. What about these guys? Open line, open line, open line. Maybe there are 2 that should have 30 ohms to ground. I don't know. Red probe on ground, black probe here. And the fact that it's the same resistance to ground makes me think that that's probably normal. So I should probably just put these capacitors back on. That is probably A-okay. Yep, that's something you gotta learn, is if you're using continuity mode to check for short circuits on like these MLCC capacitors, sometimes it will beep and it is not a problem. Sometimes it'll beep on both sides of the capacitor and it's not a problem. But most of the time when it beeps on both sides of the capacitor, it is in fact a major problem. So it's one of those things. One of those things. So just stick these guys back generally where they go. Start with those big ones. And then what I like to do when I'm reattaching like these surface mount multi-layer ceramic capacitors is I like to get just a tiny bit of solder on the end of like a micro pencil iron like this. And then I'll just tack one end down to the board. I need to get my tweezer. You can't touch that. It's 400 degrees centigrade. I can touch it. It's only 400 degrees centigrade. Get back here. So, yeah, the smart way to do this is just to touch the pad. Melt that little pad. And then just kind of slide your component on there. I need flux, that's why this is not working. Flux is kind of important for doing this sort of thing. Also, I'm going to clean my iron. It's a little oxidized on there. There we go. I am just kind of raw dogging this without using a microscope. Don't try that at home. Microscopes tend to be necessary for microsoldering. I've just been doing this for a little bit. I can get away with microsoldering without a microscope. Sometimes. Sometimes. The only reason I'm getting away with it right now is because this is a very low density board. Where did that... Oh, it's stuck to my tweezer. Yeah, you can only really get away with that kind of bullshit. Like, not using a microscope for these, like... You probably can't even see the components quite clearly, but... Let's see, do I have the resolution? Yeah, you see those tiny little dots there? Yeah, those are capacitors. Yeah, working... I just flung one. Where'd that fucker go? I saw it land. God damn it. Oh, here it is. Wow, it bounced all the way the fuck over there. I saw it hit something over here. Then I found it over here. Yeah, if you lose control of one of these, this size component, typically it's just gone. And you have to get a replacement out of the SMD book. And hope you can find out what that value was somehow, some way. Yeah, there's a reason I don't pick them up with two sides of the tweezers, because if you put pressure on them, they act like a little spring and they go... Because they're hard. They're ceramics. Made of ceramic. Ceramic and copper and nickel. So, yeah, if you use hardened steel tweezers and you put too much pressure on them, you will end up sending them fucking flying. And once you send these things flying, they are as good as gone. You'll never... It is smaller than, like, a letter on a penny. You won't be able to find it. And, you know, it's probably not worth your time to find it. Just replace it. Like, for PlayStation 5s, this is 5,000 1 picofarad capacitors that you use next to the HDMI port. That costs like $3 for like 5,000. I'll never run out. I can lose that little capacitor next to the HDMI port. I can lose it 1,000 times and be fine. Because it is the smallest size SMD component that they make. Which is, what's that size? I know, that's not the, box or bag from it. Where's the bag from that one? I don't know. I think it's like... I forget. Is it 9005 metric? No, 9005 metric is a bigger one. I don't know. I forget, but they're the tiniest fuckers. That's not descriptive enough for you guys. I don't care. They're like the ones next to the iPhone CPUs, that size. The smallest surface mount component they make. Why isn't this... That got stuck down really good. There we go. Yeah, you only really need to get like one side stuck down. I just like to tack one side down and then come in with the hot air rework station and reflow them into place. Because otherwise you gotta use such low airflow that it becomes frustrating to actually melt the annoying unleaded solder. So if you just tack one side down with a micro pencil iron like this, it becomes so much easier just to, you know, goop some flux on there. I don't even have to look at what I'm doing. I can just heat this up. And let flux do what flux does best. And those all should just kind of fall into place. I might need to poke them slightly. Where did I just set that tweezer? God damn it. You set something down and it disappears. Here it is. Turn my airflow down a little bit to get these tiny little itty bitties in the right place. Sorry if you're just watching the top of my lunch lady capped head. Try not to burn the shit out of my fingers in the process here. There we go. And there we are. All those back in place. That was probably a waste of my time. While this flux is still a liquid, let's clean that up. No such thing as too much flux, no such thing as too much alcohol. These are the laws of board repair. Okay, so since that was not the problem, I'm back to being completely fucking clueless as to why this $1,000 monitor isn't displaying the color red. I might have to use this UART bridge and see if I can read like an error code or some shit. Hell, it could be 100 things. If I could get a pen out for like this cable. I think it's... Okay, so this is PCI Express, this connector here. Looking at the yeah, okay. So this is PCI Express. This connector. So this communicating with the other board is over PCIe. So that's cool. Does that help me at all? Hell no. Lead-free soldering? Fucking not anymore. Hmm. 24MDKL. 24MD 4KL. LM 8KA. So yeah, there's a little... I found a debug only pad. So I assume it's UART GPIO, looking at like the block diagram for this ARM processor here. So I'm gonna see if I can like serial read anything going on over here on this board. Because it works, it just doesn't display the fucking color red for some reason. You know what, I probably should go back and look at, like, since this is PCI Express, I should look at the decoder board. Because this ARM CPU is going to send, you know, your display instruction from over here. It's going to send that to the decoder board. The decoder board is going to switch the IPS panel, however the fucking however the fucking IPS panel switches colors. I don't know if it's ground switching or if it's you know, multi-phase switching or some shit like that. I don't know. I haven't read that entire Wikipedia page yet. Keyword yet. So yeah, I doubt the issue is on this board. I will see if I can get any debugging through this. So let me go back to that board on the panel. So let me clean up all this flux. The decoder board on the panel. We're gonna look at that. Maybe there'll be something obvious on there, like some spilled Mountain Dew or Cheeto dust. Who knows? I haven't even got to look at it yet, so it is definitely worth tearing down. Yo, Big Cheese Man! Are you winning, son? Yeah. Trying to. How you been, Big Cheese Man? Alright, get all that, So, Cheese, I've got this $1,000 4K monitor, right? It's a Mac, it's one of those, like, creator monitors where, like, they're definitely targeting Mac users that are in creative jobs. Like an alternate to the Apple Retina displays, basically. Or the Apple Cinema displays. So, yeah, this is the LG, it's the ultrafine 4K. This stupid piece of shit only has USB-C, by the way. No DisplayPort, no HDMI. The board supports HDMI, they just didn't put an HDMI plug on it, because it's for Apple users. We don't have those. But I'm thinking the issue on this is going to be on this board down here, under the shield. Because everything works, except for displaying the color fucking red. Like, no red pixels. Everything works except for red. I actually saw a bunch of Reddit threads talking about having this exact same issue with this exact same series of monitor. So, we will see. But yeah, this monitor woke up one day and said, fuck the color red. So we're gonna try and figure it out. Try and figure it out. There we go. Rightio. So this is the PCI Express line. That's the decoder. Little BGA chip there. I'm not seeing any spilled Mountain Dew or anything. There's a debug port there. It's probably PCI Express by 1. Maybe, no, it says SCL and SDA, so that is I2C. That's an I2C port. Yeah, that pin's SCL. That pin's SDA. That's probably VCC. That's definitely ground. Cool. So there's that. So if I hooked up like an I2C sniffer, I might be able to tell something. Keyword something. So that's clock. That's the clock chip there. Hey, at least they fucking label stuff on this board. Like, all the silk screens say what the fuck you're looking at. I wonder if there are pads here that are literally, like, labeled for, like, what color they're... No, they all just say channel. Like APAN, BPBN. I don't know what that refers to. I'm not familiar with, like, IPS LCD architecture. I might have to look that up and figure out, like, how exactly these switch color. Because it could be, like, one of these, like, little MOSFETs here. Ooh, actually, that capacitor right there looks fucking toasted. Let me get you guys close up here, so you can see. I think I might have found the issue. If I bring you in, honestly, fuck the color red. Who needs? Yeah, that's what colorblind people have been saying for a long time. But yeah, like this capacitor and this capacitor right here, like these three, they look like they've got real. They're like discolored. They look like they've got real hot. I don't know. Maybe I should just do a continuity check on these guys. So Cheese, if you're still here, here's a fucking tip for you that you may have already figured out. So with your multi-layer ceramic capacitors, you take your red probe and you find any ground. So you just stick your red probe on ground, then you take your black probe, meter in continuity mode. That's the one that beeps. Right? And you poke one side of the capacitor and the other. One side, that side there is ground. This is the positive side. If you take a capacitor and you poke it and you get a beep on both sides, that's usually a problem. Keyword usually. There are a couple situations where you'll have... Well, I mean, if you've been watching the stream for a minute, Cheese, actually on that logic board, there was one of those situations where, like, it's okay that it beeps on both sides. And that's usually when, like, it's beeping, you look at the resistance. If it's, like, higher than 10, I'd start questioning whether or not it's just low impedance. But you see, I poke one side, beep. Poke the other side, no beep. That's normal behavior for capacitors. Unless they're a data line filter. If they're a data line filter, you won't get a beep on either side. But these are all decoupling. So yeah, when in doubt, just start measuring capacitors. See if you can find one that is not behaving correctly. See, like, these capacitors over here. I poke one side, nothing. I poke the other side, nothing. And that's because it's a data line. There is no ground on either side of that. It's a data line. And those are usually, like, 1 picofarad. Like, really low impedance capacitors. Sometimes you'll even just get continuity on them. Like, if you poke them like that. I see a lot of 0 ohm resistors over here. Which, we use those as fuses. In circuits like this. Because in reality, they're not 0 ohms. They're like 1 to 10 ohm resistors. And they're basically like a tiny SMD fuse. So whenever you see like a little 0 like that, always poke it and check to make sure you get a beep out of it. Because these, if something fails dramatically, these will blow wide open on the inside. They won't look burnt out, always, but yeah, when you see a little 0 like that, they're usually acting as a fuse or a jumper. Or current limiting. They're current limiting is what they are. And then I got a whole bunch of crap over on this side off camera. So yeah, these capacitors being discolored was not the issue. Was not the issue. Clock, VST, PCI Express. And this is really nice. This is a dedicated Pico fuse right here. So I've got 10 volt SCL, SDA, and ground for I2C communication to one of these chips. So that's pretty cool. So I might be able to hook it straight up to like a Raspberry Pi or something. Mm-hmm. Oh yeah, a multimeter is fucking essential kit. I wouldn't buy this unit. I got this for free. This one works, you know, obviously, but there's one that's like fairly cheap. It's like the Fluke 40 or something like that. It's like an $80 Fluke meter, pretty decent. Kiloweets also makes some decent affordable meters. Whatever multimeter you decide to choose, just be consistent. Like, use the same meter. When your meter breaks, get the same meter. That way, if you measure stuff that's important, if you're just using the same meter and that meter is consistent, unit to unit, it doesn't matter what you're using, as long as it's somewhat accurate. Because you don't use this for accuracy. You use this for just doing some basic checks. If I want accuracy, I'm busting out the oscilloscope. Or the 7, digit reference meter that I don't own because I can't afford them. Assembling a broken screen phones, putting them back together. Yeah, if you go to mobilecentrics.com, you could just get a new screen. And then when you take apart the old broken screen phone, you can put a non-broken screen on it. And sometimes people will pay you money for that. It's kind of nice. But yeah, that's good practice. But if you have one with a working screen, taking that apart and putting it back together, then you can tell if you fucked something up or not. Because it works when you take it apart. Like a good old, iPhone 7 or something is a great thing to practice with. iPhone 7 is basically fucking worthless at this point. But if it works and it turns on, you can, fully disassemble it, put it back together. And that's how you'll figure out how to work with technical stuff and not screw it up. Yeah. Alright. Measure a couple more of these. Right now, this is my prime suspect. Is this chip right here. VGA chip on a thin board that has a fair bit of flex to it. You might have a red ring of death scenario, right? Actually, oh, that's just a piece of dust. Yeah, I might need to scour this board with the microscope and see if there's a shoddy solder joint somewhere here. Because nothing looks obviously blown up or corroded or anything like that. So it's probably just going to be a bunch of painful poking around on this board. Yeah, a bunch of painful poking around. And I'll be staring at it for quite some time. Until I figure out what the fuck is the problem. But I'm almost certain it's on this board and not the logic board at this point. That makes sense, because this is where like the PCI signal becomes colors. If it was a problem, since this is PCI Express, if it was a problem with the the signal going through this logically, because it's encoding that like digitally, in like 9 out of 10 failure modes, right? If it was a problem before this ribbon cable, since it's encoding it digitally and then decoding it here, before it starts, actually switching the panel, you wouldn't just lose one color, you would lose complete functionality. Because it's sending that in packets over PCI Express, I believe. At least I think that's how that works. Sounds... I might be, like, semantically off a little bit about how PCI Express works, but as far as I know, PCI Express just works or doesn't. It's not like... The problem with this panel is it won't display the color red. So it can't be before this ribbon. It has to be after this ribbon, but it could be after these ribbons is what I'm worried about, is if it's a problem with the panel itself. Mm-hmm. If it's a problem with the panel itself, I'm just fucked out of luck. I mean, it's not my monitor, so if that's the case, oh well. But this is a $1,000 monitor. I want to give it the due diligence it deserves to try to figure out what's wrong with it. But, yeah, I'm thinking this BGA chip is probably the most likely candidate for, like, a failure point. Just because that's how BGA chips are, and, like, this part of the board is very flexible. So having one of those, like, solder balls that might be snapped or cracked is not unfeasible. They really should have, like, one of those little foam spacer pieces, like this kind of material, under this. You see that? I shouldn't be able to move it. Like, it's well supported, like, everywhere else. Except for this chip. I wonder, is there shit on the back of this board, too? I doubt it. Usually there's not shit on the back of boards like this on TVs and monitors. Yeah, I should definitely put an I2C sniffer up here and see what's going on. That is a fucking buffer chip. That's the clock chip there. It's a big tantalum capacitor. Don't know what the fuck that does. Probably a couple MOSFETs. Yeah, it's an ST part. 4.3... I can't read it. Upside down. ST Microelectronics 432 FK? Don't know. Not familiar with that chip. It's a weird form factor too. It's like one of those long SOSUPs. SOSUP 8. You don't see a lot of 8 pins that are like long and square, rectangular like that. Usually you see like 8 pins in like the SSOP form factor like this. That one's like double wide. It's like the back of an F-250, double wide. Shit, I don't know. Why aren't you displaying the fucking color red? We'll figure it out. I know we will. And it's the whole panel. It's not just like one section of the panel. It's the whole panel. Won't display the color red. Ah, shit. I don't know. Yeah, it's gotta be this chip. It's gotta be. I wonder. Battery looks like it's about to explode. What battery? Oh, the iPhones. Oh, okay. I didn't read the messages above that. I'm like, huh? I can read sometimes. Yeah, that's what I'm planning on doing. Old Samsung tablet. Just needs a new battery. Trying to revive it. Yep. Mobile Centrics. Or, Injured Gadgets. Also sells good parts. Working on the iPhone 7. Yep. Shattered screen. Everything else seems fine. Battery looks like it's about to explode. Yeah. Yeah, I usually don't have that problem with the iPhones as much as you do with some of the older Samsung devices, but yeah, old lithium-ion cells will release what is it? Fluoride vapor builds up inside the cell, something like that. I know the gas that builds up inside like failing lithium-ion batteries is highly toxic, and you should never breathe it. Like if you puncture a lithium-ion battery, like that gas is highly toxic. I think it's fluoride is like the thing to be concerned about with that specific gas. I don't know, but I think it's gonna be this BGA chip. I bet if I reball that, I might not even need to reball it. I might just be able to reflow it and see if that works. Actually, yeah, fuck it. I'm just gonna reflow it and see if it works. Reflow, reassemble, and give it a shot. If reflowing it makes the monitor display red, I'll actually properly reball the whole chip. Because we're not a reflow shop here. But for a lack of anywhere else to fucking figure anything out, I need a little bit more airflow than that. Give me like 25. And I should probably put like a fucking piece of metal shielding that cable. You don't want to melt that. Yeah, melting those cables is not a good idea. Give that a little bit more flux. No such thing as too much flux. Now I actually do have to be careful when I clean this up. I usually say there's no such thing as too much alcohol, but if you get alcohol in the back of a LCD panel, it'll fuck it up pretty bad. So I'm going to apply my alcohol directly to my cloth. I don't want to like dump a big puddle onto this. I lied. I want to dump a big puddle on this. Kimtech white. Where did that fucking brush go? There we go. There's your sister's toothbrush. you know, you need to clean something, just borrow your sister's toothbrush. There we go. All right. See if that improved anything at all. So that's reflowed. Get that back on there. And it's those ones. Get that lined up. Dude, I hate the iFixit driver. You see this? It just, the magnet is not good on those. Like, I have personally complained to Kyle Weens about the weak magnets on their drivers. So they know it's a problem. And they agree it's a problem, too, is the crazy thing. So maybe I should just buy a new iFixit driver. Maybe they've actually fixed the issue. Because, you know, I literally told the CEO. I mean, it was over email, so, you know, he might have just been like, oh, yeah. And then didn't do anything about it. I couldn't get, like, a read on, is that something they're actually going to work on? I don't know. But, or was it, like, a thing with the iFixit drivers where, like, they're not overly magnetic so that you can work on hard drives with them? I don't remember, honestly. But, yeah, this is a really nicely made driver, but I almost never reach for it because it can't pick up screws with the magnet, which makes, you know, workflow, doing this kind of thing, being able to pick up the screw is kind of important. If I have to use two hands to put one screw in, then it just slows me down. Alright, get you guys put up over like this. Yeah. There we go. Okay. So, next bit is this over here. Let's see, speakers, this one. So yeah, I'm gonna boot this up. I'm also gonna serial read with this UART bridge when I boot it up to see if there's any anything that might be useful as far as like diagnostic information. I know with like a UART connection you can like instantly diagnose any PlayStation that will even like beep once. But sometimes it's just no dice. I don't want to touch that AC in to the SMMPS. This is a SMMPS, also known as a switch mode power supply, or a SMMPS for short. SMMPS. It means SMMPS. That's what that's called. It's a or a switch mode power supply. SMPS. SMPS, PS, PS, PS. It's like you're calling your cat, you know? Switch mode power supply. Schmispips. You know, I really wish this monitor had fucking buttons, you know? It's one of those, you know? I don't know how long you've been here, Big Cheese Man, but this monitor only has USB Type-C Thunderbolt and has no external buttons. So if you don't have a MacBook Pro made after like the year 2017, 2018, or like an Intel NUC or something that is, you know, supports Thunderbolt, yeah, if you don't have a CPU with integrated graphics, or a few very specific graphics cards, you just can't use this monitor. But, you know, it's made for Mac users. Like, it's specifically advertised as a monitor made for Mac. So, like, yes, you can use it with Windows, but... Oh, I didn't put the fucking sticker back on the USB. Well, I'm just putting it together to test anyway. Who gives a shit? The outside of the Type-C connector is ground anyway. Oh, wait, it goes on this side anyway. I'm worried over nothing. There we go. So then this goes here. Pick that little guy up. Like so. PCI Express ribbon plugs into the PCI Express ribbon plug. Then this bitch goes here, plugs in like so. And you know the shitty thing about repairing this monitor, Big Cheese Man? Is, I can't even fucking test this bitch once I put it back together. I gotta drive over to the other repair shop in town, talk to my buddy David, and plug it into his MacBook Pro. Because I don't have a fucking modern Apple device. For good reason. I mean, like, why the fuck would I want one? And I tried using this fancy fucking cable. So this is a USB Type-C to DisplayPort, and it's bidirectional. But the problem with this bidirectional cable, my friends, is my motherboard doesn't have integrated graphics. I don't have an integrated graphics CPU, and the RTX 3080 for the Win 3 by EVGA doesn't support DisplayPort alternate mode. So all the connections from here to my GPU are correct. It's just the GPU driver doesn't know how to fucking say, hey, change pin 13 to pin 6. So, yeah, there's a $35 cable I bought for no reason. I'm sure it will come in handy someday. Someday. Either that or, I mean, I've got it at Micro Center. Micro Center has really good return policy. I'll probably just return it. Because, why the hell would I ever need that? It's such a weird cable. Oh, by the way, Big Cheese Man, I let my wife dye my hair blue. So, that's the thing. She decided to convert me into a liberal. I'm now a blue-haired liberal. Or at least that's the joke. Yeah, suddenly I feel like my opinion doesn't matter. Yeah, I have that sneaking suspicion that my opinion no longer matters. Not like it did in the first place. All I need to do is get on Twitter now, right? I got the blue hair. All I need to do is get on... Oh, actually, I guess Twitter is now like a conservative hellscape, isn't it? I don't know. I've never used Twitter. It's like the Elon Musk echo chamber now. Is that what happened to Twitter? We all use Blue Sky now? Or something like that. I don't know, I'm too busy playing with electronics to keep up with current events. I'm like out of touch with things normal people care about. Which is really not something you should be bragging about, but I don't know. I don't care either way. I'm pretty sure this one is these two longer screws. They're the same thread, but it's not these short flat ones. These short flat ones go there. I end up using these long ones. I'll like long screw damage the fucking panel, which is not something I want to do. Because like I said, fucking $900 monitor here. Imagine buying a fucking $900 monitor, right? And like, what was it? 4 months out of warranty, it just stops fucking displaying the color red. Like, imagine. I'd be pretty pissed. Because, like, my $110 ViewSonic, cheapest 144 hertz panel. Like, the cheapest 144 hertz panel when I was building my computer. First monitor I bought with my setup. That shit's, what? I bought it in 2020. It's 4 years old now. It's still kicking like a fucking champ. Mm-hmm. And it is the cheapest fucking thing that works. But no, this $900 fucking monitor. 3 months out of warranty. Just decides, fuck the color red. I'd be pissed. I'd be like calling LG support and be like, dude, this is obviously a manufacturing defect. I don't care that it's outside of the warranty period. I feel like if you took any pride in your engineering whatsoever, you would replace it. I'd just be calling them up or emailing them just like, skill issue, dude. Get good. I'd be Louis Rossman in their ear like, stop manufacturing disposable garbage. Honor your warranty. Stop being a piece of shit scumbag company. I don't know if LG's all that, but actually LG is far from good, but they're not like Apple level terrible. They're a big tech company. All big tech companies kind of suck these days. Name a big tech company that isn't actively screwing over all of its customers. I'll wait. Actually, I guess Micro Center. Micro Center is the only... And they're not even like a big tech company, you know? They're a large company that sells tech, but they're not a big tech company. They're not developing product. Well, they do develop products. Yeah, maybe that is the only big tech company worth a shit, is Micro Center. Because they're like good to their customers. Their warranties are good. They're mostly a retailer, but they do manufacture shit. Like the CSP32 is an Inland brand, which is Micro Center. And like it's its own board design. It's not like a stock standard expressive 32 board like from Arduino or anything. It's their own design. And they have cables and shit, you know? Like, there's all kinds of inland branded shit. They even have their own, like, flash drives and SSD manufacturing. So they do make stuff. And they don't suck. They might be the only ones. They might be the only ones. Alright, where's the, here's the case. So yeah, when I'm working on a panel like this, by the way, I, packing tape on the panel so that we don't scratch it up. Because, like, one tiny little ball of solder or wire or something on my desk here, and, all of a sudden you have a big gash in the fucking monitor. Yeah, we don't take that risk. This monitor might be hot fucking dog shit, but at least it has, like, a satisfying, like, click to it when you're putting it back together. It's got a good, like, good display crunch. Oh, yeah. Come on. Those bottom clips don't want to fucking go. So yeah, now I gotta lug this all the way back out to my buddy's repair shop to test it because it's a fucking USB-C only. Like, what you see is what you get here. You got Thunderbolt, power in, and then an internal USB hub, and that's all you get. No power button, no, like, physical control buttons. Doesn't even come with a remote. It's only, like, on-screen control through LG's terrible dog shit proprietary app. And only Thunderbolt. So yeah, this is made for Mac users through and through. Like, this would be the single worst choice for a monitor for anyone but a Mac user. Unless you're on, like, something like an Intel Nook or some of those Lenovo Intel laptops that have Thunderbolt native support. And boom. Where's the fucking... Here it is. Yeah, so, poor dude with his fucking $1,000 monitor that won't display the color red. I'm moving on to the next thing. Alright, what else is on the fucking chopping block today? I mean, it's a really nice 4K display when it decides it wants to display the color red. Here's what's next. Scar Audio Class D amplifier. Another one. Yet another one. These things haunt my fucking nightmares, dude. But I've already diagnosed this one. I know what's wrong with it. So it's more just doing the work to fix it. You'll probably be able to tell what's wrong with it if you like look. It's kind of hard to see, but yeah, this section of MOSFETs looks like it's got very fucking hot, and this section does not. And they are different date codes. So, yeah, all of these MOSFETs are old and all of these are new. So somebody's fucked with this. It's been repaired before. And I think these ones are ready to go. I think they just did, like, there's a problem in this section, they just replaced this section and then left this because it was working. But with Class D amplifiers, if you have to replace one MOSFET, replace them all. If one goes, replace them all. And there's a good reason for that. It's called transistor pairing. Because if these guys have a slightly lower threshold voltage or a slightly different capacitance, it's going to make these guys work exponentially harder. You want all of those metrics of your transistor to be as close as possible to each other. Because as the temperature rises in the circuit, as these get hotter, their resistance increases, and they have to work harder to switch, the same amount of current. And if one is switching more efficiently than all the rest, the one that's less efficient is going to take even more abuse, thermally speaking. So it can be a big problem if you have like 4 new MOSFETs over here and 4 old ones over here. The old ones over here are going to get absolutely fucking demolished. When they're put under like a heavy load, which this is a car subwoofer amplifier. They're gonna fucking push this thing to its goddamn max. You gotta think about the kind of person that buys a car subwoofer amplifier. That kind of person buys this to play their music very loudly and very obnoxiously. So, of course, this output section is going to get absolutely demolished. Yeah, I see solder flux all over the back of this. Yep, somebody's been in here before me. They didn't do too bad of a fucking job, honestly. Like, I have no complaints. It's just they should have done all of the MOSFETs at once when they did it. You see how these ones are shiny and these ones aren't? It's because these are new and these are not. In fact, these are probably used even. Like, I see solder all the way up to the base of the MOSFET. So those probably got taken out and tested, because you have to test these out of circuit to get a good read on whether or not they're working. Oh, I just fucking sat on that heatsink. That makes a really cool sound when you hit it. Alright, so yep. Those ones and these ones too. And these guys up here as well. We're just gonna pull the entire output section. and replace it. These are IRF 640Ns, very common MOSFET. I have a fuck ton of them somewhere. I'll have to track those down. Oh, I turned off my fucking soldering irons. Why? I'm not done. We're doing the Louis Rossman special. We're working till 4 in the morning. Just a brief intermission while we wait for the fucking soldering iron that I turned off for no reason to heat up. I'm going to be using some leaded solder and some flux. And pretty much I just bridge all 3 pins and just hold the iron there for a second and give it a tiny little wiggle and it just falls out. So we'll just drop all 2, 3, 4, 5, 6, 7. It's what, 8? Oh no, 6, 12, 24. All 24 MOSFETs, we're just going to drop straight out of the board and replace them all. Because this one's going into protection mode because it's not getting Class D switching. And thus it is getting DC on the speakers. DC on the speaker terminal. Protection mode. The usual with this sort of thing. Most common problem is these guys decide to unalive themselves because you turned the gain knob up because you thought it would make your bass louder. That's what really happens with a lot of these car audio amplifiers is people that don't know what they're doing drive the wrong impedance speaker. They turn the gain knob up to try to get more volume out of the same wattage amplifier, which that's not what that knob is for. And if you turn it up too high, if you turn the gain up too high, you're just going to cook your output section and, clip your audio signal, burn it up, smoke it up, and then you're going to be paying me money to fix your stinky subwoofer box. At least, fortunately, this amp doesn't smell like cigarettes, weed, and black ice little trees. This one doesn't have that distinctive subwoofer amp smell of weed smoke, little trees, and fucking gooch. Space gooch, I don't know. Just ass. Yeah, there you go. Ass, weed, and little trees. That's the smell of subwoofer amplifiers. Or car sub-amplifiers specifically. Because that's just what the cars these go into smell like, is ass, little trees, and weed. Like I said before, the kind of person that buys and installs this in their vehicle is a very specific kind of person. I don't like to stereotype people, but the kind of person that's interested in this thing is either A, just really into audio, autistically into audio visual equipment, or you like waking up the neighbors at 3 in the morning, going down the road, going brrrr, brrrr, And, I'm not a huge fan of, listening to some guy 3 blocks away waking up the neighborhood. But I will certainly take his money when he blows up his fucking amp, I will happily take his money. And, there is a time for, having some tasteful subs in your fucking car, And I kind of get it, chasing, extreme levels of audio. But most people that are buying these aren't, making high-end extreme audio setups or anything like that. Most people. Keyword most. There's some guys that are like running 4 of these in parallel. They're like, yep. If the rear view mirror don't shake, it ain't enough, right? Alrighty. There we go. So yeah, as you see, you just bridge the 3 pins of the MOSFET. Heat it up, give it a little bit of a wiggle, and they just fall right out. Nice and easy. You don't have to fuck around with solder wick. You don't even have to fuck around with the vacuum station. No solder suckers. Nope, you just bridge all 3, heat them up real good, and let the MOSFET fall right off the board. And that's the beauty of leaded solder. It's just nice like that. I did not get enough flux over here. Yeah, there we go. A little, just... There we go. Oh yeah, I forgot to mention this step. You gotta add flux to all of those joints before you start bridging them. And the flux will make it so that they don't want to like bridge quite as easily. So there's a little bit of a technique to it, I guess. It's not hard though. I could probably train a grade schooler to do this. Yeah, that's one thing I just don't get, is a lot of people are like, soldering's so hard, I suck at soldering. It's like, well, soldering is really, really not hard if you use the right tools. Like, if you're trying to do soldering with the wrong equipment, you're gonna have a very fucking bad time. Like, people will tell me, oh, soldering is so hard, how do you get good at soldering? And then I look at their soldering iron, and it's one of those ones that just is a cord that plugs straight in the wall. No temperature control, you know, it's gonna have really poor, like, you know, heat exchange. And you're like, yeah. And then you're like, what flux are you using? And they're like, what is flux? And you're like, okay, so that's why you think soldering's hard. I got news for you, buddy. You know? It isn't black magic. Come on. There we go. That one wanted to be a little finicky. Just pop that dude out. Come on, come on. Oh. I need to put like something under here. I don't have that I was hitting the bottom of the mat. There we go. That's the money. Oh, and if you use the side of the iron instead of the tip of it, you transfer heat quickly, more efficiently. That's why I like chisel tip irons. Because you got a flat surface that you can put up against your flat board, you know? Get it to heat up nice and quick. Boom. There's every MOSFET removed. There you go. 24 IRF 640Ns. Now step 2, suck. Let me turn that heat up. Yeah, turn that way up. And a little bit more flux. If you want to go fast, doing this with a vacuum gun like this, what I do is I run my my regular iron like a joint ahead. Like I'll run this one space ahead of this, so the solder's pre-melted, so I don't have to, you know, sit there and wait for the solder to melt. Come on. There we go. There we go. All those, actually some of these up here are, gonna need, sucked from the other side. You see why they'll need sucked from the other side is like when you pull those, I don't know if you can see that, but you get like these little spikies on this side of the board, and those will keep melting back into your holes. That's the one disadvantage to using the pull-through method is, cleaning up the through holes after the fact becomes a bit more work. That one right there wants to be a bitch. If one of these decides it wants to be a bitch and like there's a little piece of solder like stuck down in there, just flow a whole bunch of new leaded right in there. Just hold your iron on it for a sec. Boom, clear. Yeah, some of the time it'll just fucking like oxidize weird. I need actually this will probably work. There we go. Sometimes the tip of these vacuum stations gets just like a little bit clogged. You gotta shove something pokey in there, clear out the burnt flux or what the fuck have you. Right there, I just sucked a fucking piece of some kind of junk. And it instantly was like half the suction. There we go. Where's my I've got a little squeezy bottle. If you look over there where this lives, I've got a little squeezy bottle of distilled water that I use to fill that up. And I seem to have misplaced it because it's supposed to live over here. Usually it ends up on the floor is what happens. Lord knows why, but it always somehow ends up on the floor. Where did that guy go? I don't know, we'll do this the stupid way. And then just take this and hold it over the bin. There we go. Solder sponge is wet again. Oh, there it is. I found it. It was on the floor. It was, in fact, on the floor. See, the problem is I'm really lazy about refilling it. And when this thing is empty, it's really easy to knock it over. But when it's full, you know, knocking this off my desk is a lot harder. Alright, back to giving this thing a good sucking. A sucking worthy of your mom. Oh shit. Oh no. Oh no. Those were SMD components on that post-it note, and that ended up on the floor. Well, they were bad ones anyway. Those were the ones I had to replace. I already know their values. I already measured them, so they're already in the Digikey cart. It just irks me that I managed to drop that thing on the floor. If those were important parts, that would have been a major fuck up. But those are not important parts, fortunately. Fortunately. Let's see, give that a... Good. 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 That one sucked. A touch more. Alright, all those are good. You know, I probably shouldn't work till like 4 in the morning, because that once I'm done working, I gotta wash all this shit out of my hair. Yeah, I let my wife turn me into a blue-haired liberal, so now my opinion no longer matters because I have blue hair or something. I don't know. I'm a good husband like that. I let my wife guinea pig whatever hair color or what have you. I let her guinea pig all that stuff on me. Hell, I'll even admit to enjoying it. You know, fun colors make everything slightly more enjoyable, right? Why not your hair? Cool. Alright, that's prepped. So now I need to go find where the rest of my RF 640 ends are. These ones I are brand new ones I installed on a board, and then it was like a preamp issue or something. So they have a little bit of solder on them, but they're brand new and working. Alright, now I've got a whole fucking case of these over here somewhere. Those are 3205s. It's not in there. I think they're up on... Those are 3205s. Yeah, I seen them over here not too long ago. I've got like a whole case. This labeled 640N. I just need to track that down. I'm like this close to saying, fuck it, I'll find it tomorrow, but... I might need to go order more of these. Or I could just steal these ones. Because these are all brand new. And this board is fucked. Yeah, I tried putting new power supply on this one. So these are all brand new 640Ns. And these transformer windings are completely fucked. So yeah, I ain't bothering with that. So this became a donor board pretty fast. That's why I have so many. I had 4 of these come in at once, and they were all fucking completely unrepairable. Which, that was fun. I enjoyed that. Oh yeah, I can't lose that little chip there. That goes to PlayStation 5. Let me just put all of this on like a piece of tape or something. Then go stick it to the damn console so I don't lose them. Now, seeing as somebody replaced half of the MOSFETs on this amp, I'm going to go through these and test them. Because I bet half of them are good. But I'm not going to do that right now. I'm just going to shotgun in a whole new output section into this. And call it a day. I'm going to go stick this at that PlayStation. Yes, sir. Yes, sir. All right. Those are 640s in that power supply, right? Yep, 640Ns. All brand new ones. Same batch. Yeah, I wasted like 1, 2, 3, 4, 5, 6, 7, 8, 16. What's 16 times 4? That many brand new MOSFETs on a bunch of donor boards. Yeah, I was not quite happy about that. But hey, that's why we got a bench fee. And like the parts are still good. It's just more work to use them than the ones that come out of the tube. Now the board wasn't like this fucking terrible when I did install these. This has just been banging around the donor bin, which is why it looks so crusty and nasty. That's because it's been living on my floor and in the donor bin, and the donor bin is like right next to the ultrasonic, so when I pull stuff out of the ultrasonic cleaner, all that water, sometimes like I just drip water straight into the donor bin sometimes. Yes, it's distilled water, but you shouldn't let it sit on things for extended periods of time. Which is probably why there's like minor corrosion. It's like just surface corrosion. Because, yeah, it's non-conductive, but that doesn't mean it's non-corrosive. It will eventually dissolve. You know, metals and ions off the surface of your PCB, and it will eventually cause it to corrode if you leave distilled water, especially dirtier distilled water. Sitting on, you know, exposed pads on the circuit board. Because there is just the same amount of oxygen in the air, right? Mm-hmm. As anywhere else. Alrighty. I should probably check these, because with those coils being basically a short circuit, some of these might have got used. No, wait, that's not how that works. These can take you know, the raw 12 volts source to drain in reverse and be fine. These are 200 volt FETs. So, yeah, you're not even getting close to their breakdown voltage, even with a car battery hooked across them. Now, you hook the car battery up to the gate, that's another fucking story. I've actually seen that happen before. I've even done that accidentally. I was poking around with some probes on one of these way back when I first started working on car amps. And I poke the, while it's powered, mind you, I poke either drain to gate or source to gate. I forget which one. But I short, I think it was the source. Yeah, I think I shorted the source to the gate. So I basically dumped a car battery straight into the gate of the MOSFET, and it went pop and lit on fire. Good times. Good times. Alright. Yeah. All of these are brand new 3205s here on the output section there too. So I should probably unsolder those at some point. These 3300 UF 100 volt rated electrolytic capacitors. Those are like $15 a piece if you buy them. They never fail on these amps. I never end up replacing them, but they're nice to have for other projects. Like those capacitors, I've never seen those capacitors ever fail. They're just too big to fail. Too big to fail. Kind of like the American auto industry. Bail out. Or Intel. Too big to fail. Yeah, the fact Intel is not going bankrupt right now is just a testament to economies of scale. Like, Intel is the only, like, semiconductor company with fabs in the United States. So even if they, like, fucked up worse than they already have, they're gonna get bailed out by the U.S. government because it's like a significant national security threat to not have the ability to produce semiconductors or to rely on a foreign adversary for your semiconductor manufacturing in current year. So, yeah, that's the thing. Wouldn't that be nice? Just having a company that, no matter how hard you fuck up, old daddy government's just gonna bail you out. It's like nepotism levels of... Oh, I didn't fucking put this shit back in that. I didn't put this shield on the fucking monitor. Now I gotta take that bitch apart again. Dang, nabbit. Oh well. I was probably gonna have to take that thing apart again anyway. Oh, I got these tweezers because I dropped this here. Yeah, I hate working on these. You get that fucking thermal compound all over you. They like to... The backs of these boards are really fucking stabby. So they rip your gloves up. Yeah, these can be a bit of a pain in the neck. To like flip these over. Time and time again. Especially when you replace the whole output section. And then there's another issue. And you're like, shit, that one looks fucking mangled. I ain't using that. That's the problem with throwing it in the donor bin and saying, yeah, I'll desolder those later. Is some of them get fucking mangled. Yeah, don't ever throw brand new parts in the donor bin. Take your time and pull them back out of the donor board that you installed them in. It's like the walk of shame, but for parts, you know? Some of these are so frustrated I just clipped them. I'm like, I'm not unsoldering those. Fuck this. I've been doing this a long time, but I have and I have the patience of a saint, but one can only handle so much bullshit. Actually, that's an old one right there. It's got a different engraving. I probably just threw all the ones that tested good in the bin. I probably wasn't reading them. You see the new Infineon logo on this one? And that one? Yeah, those stubby ones are a different batch, so I'm not going to use them. I think I explained a little bit earlier about transistor pairing. You'd want to use MOSFETs from the same batch, if at all possible, because you want the characteristics like your threshold voltage and your capacitance, and so on and so forth. You want all of those to match as closely as possible, especially in like a Class D amplification system like this. Okay, so those are all older. Yeah, those are all older batch. I'm not going to use those 640s. Which means I should grab that other donor board that I installed good brand new parts into and get my MOSFETs back off there. I mean, come on, these are like $1.60 each. You do the math. That's more money than I like to throw in essentially the trash. There she is. There's that other donor. This one drove me fucking insane, dude. Because I got this to enable once. Only once. So I kept poking around trying to figure out what the fuck was wrong with it. But I came to the conclusion that these two little guys, somebody else had worked on them. So I'm pretty sure like something in here has been removed and put back in the completely wrong place. And I will never know what that is because I don't have a good working one to look at. So I'm just like, well, fuck. Guess I'll never know. Guess I will never know. And that was that, yeah. I'd put like 10 hours into each of them, which is like 3 or 4 more hours than you should put into anything at this price point. Because, I mean, I'm running a business over here. Just because it can be fixed doesn't mean it's worth fixing sometimes. Like TV repair. Like, there are a lot of repairable TVs out there, but just the amount of work to get those fixed, and like the very poor success rate. Like, if it's a display, you can't replace the display panel on a TV. I'm sorry. What the fuck do you think you buy when you purchase a TV, right? It's like 90%, 99% of the cost of a TV is the display panel itself. And if that's the broken thing, like, well, it's going to be cheaper to purchase a new TV. And, like, figuring out if that's the problem is, like, the number one reason, like, television repair is a dead meme. Like, television sets used to be a major investment. And, like, CRT, like, you know, old ray tube TVs were worth repairing, and they were actually repairable, too. It wasn't like these, like, you could tell if the display was the problem, because if the tube broke, you would hear it, you know? They're a vacuum tube. They go pop when they break, right? So when they stopped working, it was almost always like one of the things that could be fixed, like the driver board or the power supply. Or like the TV tuner. Depending on, you know, what the fuck gave up on it. Sometimes it would be like the flyback for the CRT. Shit like that. You know, TV repair used to be like a a fairly common thing, but these days, like, 9 out of 10 TVs that I decide, fuck it, I'll do a TV. I regret even, like, bothering looking at it. Because it's a fucked up display, and there's, like, literally nothing you can do. But hell, sometimes I'll just do them anyway, because, you know, when somebody brings you a TV with a broken, display, you get, you get the, satisfaction of ripping out that power supply board and the backlights and selling the power supply board on eBay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and then one from over here. Okay. Almost there. Almost there, and then we can give this motherfucker a test. Not a proper test if it actually does enable, because my wife is sleeping. Holy shit! Look at this fucking... Oh... You know how I was saying I need a new soldering iron tip earlier? It's like somebody took a fucking bite out of the fucker. Look at that. Okay. We're done for today. Look at that. Oh, damn. I've never seen them fail like that. Yeah, there's just a fucking... It's like there's a fucking bite out of it. That's crazy. Look at that. It just... Oh my god. Okay, guess we're done. For today. Gotta run to Micro Center and pick up a 3-pack for $25. Because I'm out. I am out of those tips. You know, it's probably something I should keep on hand is those soldering iron tips. Anyway. I think I'm going to be streaming, like, random repairs I'm doing a lot more. It's kind of fun. Like, I was doom scrolling on YouTube Shorts, and I came across another person doing, like, basically the same job I did, and I, like, sat there and watched him for, like, half an hour just repairing shit. And I'm like, huh. You know, I don't have to pay my video editor if I'm just live streaming it, right? So, easy content for you folks. For those of you that watch the whole VOD, hi. I appreciate you. Anyway, that's it for today. I'll see you guys another time. Subscribe!